Hello, we're working on using a position time graph to create a graph of velocity versus time. So we're going to go through and just get some practice in and take a look at some samples. So as we look at this position time graph, we see hopefully that there are three distinct sections to this graph. This first linear section we'll take a look at down here, and then there's this curved section, and finally that ending flat horizontal section. So if we're going to find the velocity from a position time graph, you might recall from earlier days, to get velocity from a position time graph, it's the slope of the graph. So we can take the slope of this line using those 2 points. And the slope of that is d2 minus d1 over t2 minus t1. We've also, instead of saying 2 and 1, we've used like final and original or different things like that. But we'll stick with this as that's what we've got. Then as I go on and I get ready to stick the numbers in there, D2 would be for this line segment, the second position, the later position, which is 3 meters. So I can say 3 meters minus D1, which would be this 0 meters. So 3 meters minus 0 meters over T2 minus T1. Well, T2, the later time, is this 1 second, and T1, the earlier time, is 0 seconds. So I can say 1 second minus 0 seconds. So our velocity is the slope of our line, and then I plug those numbers in, and 3 meters over 1 second is 3 meters per second. So that means that for that 1 second, we have a velocity of 3. So this is the end of 1 second in time. This is the beginning of 0. So for that 1 second, we have a velocity of 3. Now with this section of graphs, instead of doing this middle section first, I'm actually going to end up going to this last section because this curved part in the middle is something new. We've done a little bit of these straight line segments. So I'm going to jump over to this third section where we have this point and this straight horizontal line. So again, if we're going to try to find the velocity for that segment, as it has been all year, velocity is the slope of our position time graph. So I can say it's the later position minus the earlier position divided by the later time minus the earlier time. Well, the ending position and the initial position are both 6 meters. So I can say 6 meters minus 6 meters. That goes on top. And then on the bottom, T2 minus T1. Well, T2 is 7 and T1 is 4. So I can say 7 seconds minus 4 seconds. So when I go through and I do this division, I get 0 meters for every 7 minus 4 is 3. So 0 divided by 3 is, well, actually just plain old 0. So from seconds 4 to 7, our velocity, or the slope of our position time graph, is 0. So we will just have that. So we've now done the 2 sections where we have a fairly constant straight line segments. We have this initial first straight line segment, then we have the curve, then we have an ending straight line segment. This curve part is one of those spots that can be a little bit sneaky, so we'll go through and we'll be kind of careful with it. So for this first second on this middle graph, I'm just going to fill in what we know. We know we've got a velocity of 3 for that first second. And then from seconds 4 to 7, we know our velocity is 0. So now we need to go from this velocity to this velocity somehow, and we'll take a look at this segment to kind of do that. And this is a spot where things will change up a little bit. So remember, the slope of a position time graph is your velocity, and if the slope is constant, then your velocity is constant. So that first segment, we had a constant slope, so our velocity is constant. For this last segment, our slope is constant, constantly zero, and so our velocity is constantly zero. In this segment, we see that our slope changes, and if our slope changes, that means our velocity is changing. So we start off with a velocity that's really pretty dang close to what we started with here, and we end up with a velocity that's pretty dang close to what we end the whole graph with. So really, we just are going to end up going through and making a straight line like that. And there are fancy ways to go through and calculate the velocities at all these different times, but that's really not done in any class until you have some bigger math tools in the toolbox. And then to be clear, it is possible or conceivable that there could be different ways to do this where it curves in a variety of fashion to go from this point to this point. But in classes that are at the level we're at right now, we generally just assume that that's a straight angled line down there, like the beautiful purple line that's on this graph. So we did that first section by finding the slope. We did this last section by finding the slope. And then this middle curved section, we said, well, the slope is changing, so our velocity is changing. And we ended up just kind of trying to follow the trend from here to there. And that's about that. If you guys have any questions on this stuff, please send me an email. Have a good one.